Assalamualaikum and good evening, everyone. So today we met here to discuss about our project-based learning assessment. So can you guys see the scenario that Shazwi shared on the screen?
Yes,
I can see the screen.
Okay. So before we start, I think we need to read first the scenario. So let's read the scenario first, okay? Okay. So basically, what we need to do is our task is to assess the distribution network in Wangsa Maju, Kuala Lumpur, which is actually struggling with overloading, unbalanced loads, and also outdated infrastructure. So what we need to do is firstly is to define the problems and the goals. So is there anyone willing to share their opinions and thoughts about this?
Can I share mine?
Yeah, sure.
So basically, in my opinion, we can see from the scenario.
Okay.
Basically from the scenario, so the main issue is the rising electricity due to demand to urban growth, right? So I suggest to transformer. We can see are overloaded and feeders are outdated. So I guess we can put our goal is to improve efficiency and reliability while planning for future expansion. So I guess the goals is basically based on our scenario.
Okay.
So what you guys think?
I would say I would be totally agree. For me, I think is using solar panel. Nah, atau mostly we can say using smart grid power solution would be really help. Things like automated load balance can help make the system more balanced and efficiently. Plus, yeah, uh, easy to monitor. Easy to monitor. Plus tu we can control it in real time. So beside that, we can encourage our user to save energy during the peak hours. Also, maybe during the peak hours, mostly we using the load is overload. So by using that, we can reduce the load by using the power grid system.
Anyone
Yes,
else?
that's true, Jui. So can I share my opinion?
Please.
Yes, please.
So, and let's not forget to integrate renewable energy solution. Installing solar panels can reduce strain on the grid, especially during peak hour. So, additionally, combining them with battery energy storage system can improve reliability and support critical load during outage. So this approach also align with the government vision for sustainability and net zero goals. And we can also consider the increasing population density in Wangsa Maju. And with more high-rise residential units, the load per square kilometer is higher, and that worsen the stress on outdated infrastructure. Thank you.
Is there anyone
So
else?
Faiz, I think you can open your mic.
Okay, and I think everyone are giving many good points. So let me give my opinion on our problem statement. I believe the Wangsa Maju's distribution network is an inefficient due to aging infrastructure and unbalanced load. It requires upgrade for reliability and scalability.
I think everyone have shared their points about the problem that we encounter. So before we move on, can I ask Shazwi to jot down the previous point, please?
No, boleh. Jap.
Yeah,
Uh,
take your time.
okay. Autogrid system during peak hour. Lepas tu, after that, when uh, renewable energy, solar panel. Renewable energy. So another point is maybe we need to distribute network more efficient. Also because of the aging infrastructure, like I said before. Maybe we can say we use what do you call maintenance.
Yeah,
Maybe
that's
right. Eh, boleh.
Are you done, Zui?
Done that.
Um, okay, can we proceed to the next step?
Boleh.
Yes, sure,
So
sure.
basically, the next step we are going to generate our hypothesis and solution, right?
Yes.
Yeah.
Yes.
I guess we need to brainstorm the solution that we can do to solve the problem, which is Faiz already talked about the problem of our scenario. So what do you guys think of any technical upgrades that we can propose on our scenario?
Technical updates.
I think for the generating hypothesis and solution, I have a few suggestions. Can I share with all of you?
Yeah,
Yes,
sure.
Sila.
yeah.
Terus. Sure.
So I think we can upgrade the transformers by replacing the old unit with higher capacity smart transformer equipped with IoT sensor, and we can monitor the load, voltage, and temperature in real time. So the other suggestion is this smart transformer allow for predictive maintenance and faster fault detection, which is minimize unplanned outage. And I also believe we need to reconfigure the feeders. We can implement loop feeder system, which offer better load balancing and provide alternate paths for power during faults and improving service continuity. And from a broader view, introducing underground cable in key area could improve system reliability and reduce power interruption caused by weather or external damage. So that's is for my suggestion.
Wow, that is a very great idea. But anyone else do have any idea on our hypothesis and solution?
For me, I think we can also install smart meters and the software called advanced metering infrastructure. Because I think the purpose for the real-time monitoring is often people didn't put that much importance in it. So if we install the smart meters, the respective person or the management can monitor the condition of the residential distribution network more efficiently. So basically, um, that kind of upgrades can really help our problems. I think that for me, that's for me.
Uh, all right. For me, I would say, like Iqbal said before, the upgrade the transformer. But I think it's better if how about we upgrade around the consumer. For I think it's better for the consumer. Maybe they can use solar since we talk about renewable energy. So maybe the consumer can start or they can try to install the solar panel on the rooftop. Also install it with the battery storage. The, if because I say we use the solar panel with the battery storage, for example, if during the peak hour, the house can use the solar panel directly for the power. But during the day or night time, the house can use the power from the battery. So it's more like not totally we can say uh, can reduce, but at least we can manage still be able to manage the use of energy. Also, maybe if the owner, the consumer, maybe for the longer run, maybe they can try to install with inverter. So, for example, they if they try to use the solar panel with battery storage, then they install also the inverter. So maybe uh, the house be more efficient. For example, during the peak hour, maybe they use energy from the TNB. Example, maybe around 50%. So they use another 50% the energy from the solar panel. But as I say before, it be more like more efficient rather than we totally use 100% from the manpower such as the transformer. I think that's all for me. But maybe yeah, like I said before, it's a word. We can say we look out to it for the future. That's all for me. Thank you.
Mm, okay, everyone gave a great ideas.
Um,
So,
Sorry,
and
Pain, can I add some point?
yeah, sure.
So I believe we need to do the feeder configuration. We could use load feeder to balance the loads and add redundancy. Loop system also improves service reliability since power can still flow through alternative paths in case of a fault. So that's my point.
Mm, I guess everyone already give everybody ideas and a great ideas, I think. So again, can I ask Joey to collect all the point together?
Okay, okay. First, we can say upgrade the transformer, right? Yes.
Mm-hmm.
Upgrade the transformer. After that, like Shira said before,
Smart meter.
using smart meter. All right.
Smart meter for real-time monitoring.
Real time monitoring. So, rooftop solar panel with inverter. Okay, that's for me. Long run, long run.
Thank you, Joey.
Okay.
So the next topic is analyzing issue and disability, right, Shira?
Yes, correct.
So can we lead the discussion for this? Is it
Yeah.
that you guys okay?
Yes.
Sila, terus. Can.
Yes, you can.
So okay, thank you, guys. So let us analyze the potential challenge that may occur for our suggestion of the solution just now. Joey, what's your opinion on the renewable energy that you mentioned just now?
For me, I say for the renewable energy, I think it really depends on how we get support from our government, also for TNB. As for like in Malaysia, I say if we use the net energy metering, we call NEM. It's more like solar panel is more affordable, and also you can maybe attract more user. But of course, we still will need because of the install area, we need at least we can say around if the size this totally depends of the size of the user. For example, the bigger the house, the bigger the solar panel. That's the probably the factor that we need to see. Also, maybe for example, more on Malaysia, we can say that right now we say it's more housing is more like more apartment. So to use the solar panel, it's quite problematic. But as I say before, maybe if we can make a bit space for the solar panel around the next to the building, maybe we can you know uh we can make it work. That's for me lah, from me.
That's correct.
Wow, that's a good opinion, Joey. So how about you, Shira?
Uh, for me, I think if I want to touch about your point, Kamal, at the first part, which is the transformer upgrades. We do know that when we want to upgrade something, it will cost some money. However, for the transformer upgrades, it's actually cost a lot for anyone, for any type of project. But if we look at traditional transformer, it's actually have a more cheaper upfront cost compared to smart transformer. However, they lack the real-time monitoring. So, if you choose to upgrade to smart transformer, we can actually avoid the future cost of emergency repairs, and we can actually reduce more downtime. And also, when we upgrade our traditional transformer to smart transformer, it's actually contribute to more energy efficiency. So, smart transformer can reduce the losses of energy by optimizing voltage regulation. So if we look for 5 to 10 years in the future, we can reduce a lot of costs. We can reduce a lot of energy waste that can save us more uh, operational costs. That's my personal opinion. How about you, Faiz?
Yes, thank you, Shira, for your opinion. So, Faiz, can you let us see your opinion?
Okay, for me, configuration, performing a detailed load flow analysis is essential. This analysis how through the distribution network, including voltage levels, power losses, and the loading of various components. Accurate load flow studies are crucial for making informed decisions about how feeders should be reconfigured to enhance reliability, reduce losses, and balance the load more effectively. Like electrical transfer, ETAPs provide a comprehensive platform for designing, analyzing, and simulating electrical power system in a virtual environment. With ETAP, engineers can model complex distribution networks, simulate various operating scenarios, and evaluate the impact of different feeder configurations, all without making changes to the actual system. This ensures that the proposed reconfiguration strategies are both technically sound and operationally safe before being implemented in the real world grid. So next, how about you, Pain?
Mm, I think I do believe smart grid need cybersecurity, right? Because this is to measure since we need to protect the system. So I think for the recommendation later, we need to mention about the cybersecurity that related to smart grid. What do you think?
So I think that's the excellent analysis, everyone. It's clear that while solution we've discussed have strong potential and each come with its own set of challenge, financial, technical, and policy related. So, for example, smart grid technologies open new risks, especially related to cybersecurity as we digitalize the grid, and we must also invest in encryption, firewalls, and instruction detection system to safeguard the infrastructure. So also implementing time of use tariff and demand response program can help manage peak demand, but this require coordination between TNB, consumer, and policymaker. So that's the analysis issue and feasibility. And I pass to you, Shira.
Yes, with F. So basically, everyone has given their good
Opinion.
and excellent points. So from this, we need to discuss about our data sources, where we can get the data correctly, how can we validate our proposed for this project. So, is there anyone wants to start first?
So for the information and sourcing validation, we definitely need to back up our proposal with solid data. Besides the usual report, I think uh, we also to need to refer to SEDA Malaysia. It's about the solar trade. For example, as we know, they have the good state. Also, for the case study, we can learn from the case study from the past project. For like even the international nation like Singapore, because as we know, Singapore solar energy is among we can say that among the best also, and we can still learn from them how to manage using the great energy from the solar panel and use it on modern housing. So I would say because of that, I would say maybe we can still learn from them and have a good idea so that maybe that's suitable for us housing in Malaysia. So for I think we can uh, divided the task. Maybe uh, Shira and Pain can focus on technical part, and I myself, Ikmal and Faiz can finding the related to do the case study for the renewable energy for the solar panel. So Pain,
But I think we can review the TMB's annual report. This is because basically they must have many useful data for our scenario. As we know, TNB always take the data from the customers, right? From their clients.
Yeah.
So the Institute of Electrical and Electronic Engineering, which is IEEE, papers on smart grid can also support uh, our technology recommendation, I guess. So, what do you think, Shira?
Um, I agree with you because that kind of papers actually very helpful to us. But in my opinion, we can also review case study from one of the Penang Smart Grid pilot project, which I believe will be useful for our project. Why I say that because based on my readings, they face similar challenges with our scenario, which is the urban demand growth, and they implement the smart technology for the project successfully. From what I read before the project focus on advanced metering infrastructure, which I suggested just now, and automated fault detection. So within 2 years, they successfully reduced the outage durations by 30%. So that's actually a really good value because the system could isolate the faults and they reroute the power automatically. So that will be really helpful to our problem for the residential distribution network in Wangsa Maju. And also their real-time data analytics actually help them balance the load dynamically. So during peak hours, they could incentivize the consumer to reduce usage via time-based pricing. So I think that kind of approach that they have done for the Penang Smart Grid pilot project can we take example to propose in our Wangsa Maju project. Is there anyone agree with me?
But Shira, we we should also consider the differences. Penang pilot was small scale, and while Wangsa Maju is a high density urban area. We need to adapt the solution for larger infrastructure, maybe phase our rollout instead of doing it all at once.
Okay, okay. Understood. Mm, is there anyone else want to add something?
Yeah, can I?
Yes, sure.
So we can also cite international example like Singapore's grids upgraded. They have implemented smart substation, underground cable, and digital monitoring system, proven strategies we can adapt locally. So to strengthen our proposal, we should also validate our ideas using load forecasting based on Wangsa Maju project population growth. And local new article and city development plan will help us in this area. So and then forget Malaysia also support renewable integration through scheme like net energy metering, NEM, and green technology financing scheme, GTFS. And we can reference those for financial visibility.
Mm,
So, can I hear your opinion?
Okay. And what about if we local news articles or reports that talk about Wangsa Maju population growth? I believe this could as the population in what Wangsa Maju grows, naturally the demand for electricity will increase as well. This could be due to new housing developments, commercial areas, university, or even infrastructure upgrades. Local news can give us early signals about these trends, like upcoming high-rise apartments, shopping malls, or transit projects, which may not yet appear in official data set or utility reports. By reviewing these articles, we can get a clearer picture of where the load is likely to increase in the near future. This helps us anticipate points in the distribution network and plan reconfigurations accordingly. For example, if a new residential area will house thousands of people, we can check if the existing feeder can support that load or if adjustment are needed. So, in addition to technical simulations like load flow analysis using ETAC, combining that with real world context from local developments gives us it bridge the so opinion.
So thank you for the all the your opinion about how to find the information and also solve the problem on Wangsa Maju. Like you said before, maybe we can use many source to make sure that probably that we can search for the suitable solution for this problem. That also we can maybe we can doing for the next area as we know in Indonesia the consumer on the electricity is uh, adding, as we can say, is more using more day by day. For example, as we know, Malaysia is a growing country, so maybe by using this, maybe we can on hold our energy use by day. So make sure that all the system we have today probably can use for long time. That's all. That's all I think. So thank you.
Okay, for the lastly, let's finalize our our slide here. And does anyone have suggestions for clarify and visuals?
I think for me, maybe to make sure that we can see the after, before and after, we can try to use the diagram. So for example, from as for before, we can say like, oh, before we try to install all the solution, the the uh, the power consume is like this. So example, maybe we can set also the problem, but maybe after we try to install all the solution that we discussed before, and then we can try to detect or which one is suitable, which one is like this one is not suitable for this area, but we can try for the next area maybe. Also by using this, maybe we can get more comparison. So like, okay, this is the way that we consume energy, and this is the way after we consume the energy after we try to install the solution. I think maybe we can try to make it more coloring and icon to make sure that maybe after we maybe if we need to explain to the technician, and they can more like totally understand. For example, if we try to use this and this area is suitable, then maybe, oh, okay, maybe this area, like I say, maybe the solar panel is not suitable for the apartment area, but maybe it's more like apa, uh, housing yang uh, perumahan, but not like as before, not like the apartment area. I think also, so if we can use the after and before, maybe the technician maybe can totally understand how to we want to explain to them and how to do the installation, all the solution. That's all from me. How about you, Ikmal?
Faiz, can I share my opinion?
Sila.
Faiz, can you hear me?
I think his connection is not good, so I will give mine. I think in the slide we can put a simple flowchart for the smart grid integration process, so that people can see how the integration actually flows from the current grid until we put the smart meter inside and we implement the smart transformer, and also the overall complete system. So by putting the flowchart, they can see the system better instead of just word and no visual. So I think we can insert the flowchart into the slide. How about
Shira,
here? Yeah.
before you continue, can I add the last opinion for the final decision?
Yes, of course, of course.
So in my opinion, we can add a table summarizing each proposed solution, its benefit and potential challenge. This help our audience see everything at a glance, like transformer upgrades for capacity, feeder reconfiguration for reliability, and smart meter for real-time data. And also maybe a quick flowchart showing how smart grid integration work from generation to user end will clarify our points better. So that's my point for the opinion. You can continue, Shira.
Yes, I think that the table and the flowchart will uh, go along with each other. And uh, Farahim, do you have any opinion or anything you want to add?
So Shira, you're going to put the slide for our PPT content and final the decision. So I guess let's we go to end our PPT content with a strong conclusion. So I do think to put prioritize transformer upgrades and pilot smart grid technology in phase one. So what about you guys think of on our conclusion for our scenario?
There's another.
Uh,
Faiz, where are you?
I think he has internet connection problem. So I think we basically discuss our problem really efficiently. So before we end, can I ask Shazwi to summarize what we have talked before? Just a short one so that we can go through the points.
Okay. For as you said for the summary. So in Wangsa Maju we have this distribution network problem, which is the area is need to need demand more energy to urban population area. So from that scenario, we also said that which problem that maybe we can see and we can try to use to solve the problem. So um, before, so so the solution that we give, for example, maybe we can try to upgrade the transformer, basically upgrade the transformer, and secondly, we can try do the maintenance. For example, maintenance, we can say maybe we can try to upgrade the system also, and we do maintenance maybe like for example this area, or they need to they demand more supply. So in this area we can try add more transformer. For example, not add another transformer, but that's the solution from for the supplier. For the consumer, as we can say, maybe we can try the solar panel, but on the solar panel side, we can say that sometimes it's suitable, but mostly it's done. For example, as we know, the Wangsa Maju area is more like more apartment rather than uh, the house that uh,
Landed.
ah landed house. So maybe we can try use the solar panel from the for the landed housing. But if the apartment, maybe we can try to look another solution. So for this all the solution that we give, maybe we can try. After that, we uh, uh, try to uh, try to find the information for the all the suggestion that we said before. For me, yeah, I said before, maybe for the solar panel, we can try to use we need to support from the government, also from the TNB, to make sure that we can totally uh, included the solar panel for the power consuming for the customer. Also, we need try to use the SEDA Malaysia to make sure that we totally understand what kind of the solar panel that we use, and then that's suitable for our housing in Malaysia. For like Shira say, for the case study, maybe we can try on Penang smart grid pilot, but the Penang smart grid pilot is a bit like small area. So maybe we can try find the solution on the biggest, I think. Uh, that was from me.
Okay, I agree with that. So our final decision is to upgrade infrastructure first and then integrate smart technologies. Is everyone okay with this?
Yeah,
Yes.
yes, Faiz. Yes.
Totally agree.
Okay.
Totally agree. Totally agree. Totally agree.
And let's end our discussion and start drafting the slides. See you guys again, and thank you
Thank you.
for the
Thank you, everyone.
Thank you.
Thank you.
contribution. So that's all. Okay, thank you.
Thank you.